Let's discuss the common data question 48 and 49. Okay, this is from test 6 and the topic is fluid mechanics. Okay, so what is given? A cylinder having an oil of specific gravity S is given as 0.8. So the row of oil by row of water is 0.8. So the row of oil is basically 0.8 into the density of water, which is 1000 kg per meter cube. So the oil density comes out to be 800 kg per meter cube. So now what is given is you have a cylinder where the oil is there and you have ends 1 and 2, and the pressure at end 2 is given as 50 kPa. So P2 is given as 150 kPa, and there is nothing but 150,000 pascals. The length is basically 2 meters, and we are asked to find out the pressure at the left end. So what we'll do is we will take differential element here, okay, which is a differential element which is along the length. The total length is L. Okay, so the pressure here is P2. Let the area of cross section be A, capital A, and here the pressure is P1. Okay, so on this length L, the total force that is acting here is P2 into A, and the total pressure force that is acting is P1 into A, and this entire thing is this element. This is my free body diagram of that fluid element. And now the equivalent inertial diagram will be the mass into the acceleration is towards right, so mass into A. The mass of this fluid element will be rho into the volume into A. Rho, volume, is basically area of cross section into the length L, which is capital L, into A. So now just a force balance equation will give you sigma Fx 0 to 0, so it will be P1 into A, taking forces towards right as positive. So P1A minus P2A, so that will give rise to my MA, which is density into area of cross section into capital A into the acceleration. So P1A minus P2A, the area of cross section gets cancelled, so P1 minus P2 is equal to rho capital L into A. P1, so P1 pressure at the left hand is P2 plus rho into capital L into A. So now P2 is given as 150 kPa plus density we have found out of the oil as 800, to length is 2 and acceleration is 5. So this comes out to be 5 to 10, so 8,000, so which is nothing but 158 pascals or 158 kilopascals. So the answer for this 48th bit would be C. Now similarly the same thing, the 49th bit is the same thing, just acceleration is towards left. So this equation, I mean here the acceleration in that case would be in this way. Okay, so this equation will be modified and it will be P1A minus P2A will be minus MA, because MA will be in this direction. So ultimately in the final this equation I'll be getting it as P1 as P2 minus rho L capital A. So that comes out to be 150,000 minus 8,000, which is basically 142 into 10 power 3 pascals or 142 kPa. So the answer is D for this bit. Thank you.